Introduction to differential equations and slope fields. Well, that's one slopey field if I ever did see one. All right, but we're going to be looking at a different kind of slope field. All right, so a differential equation is an equation that contains a derivative. For example, this is a differential equation, dy dx, right? That's the derivative. All right, so the derivative equals 3x squared. From our anti-differentiating skills from last chapter, from earlier, we can solve this equation for y, right? All we did is, right, you know what you cannot do? You cannot write in blue on blue. That does not work. All right, so if we integrate 3x squared dx, right? This is our integral of variable of integration. There it goes. All right, so remember we have to increase the exponent by 1 and divide by the same thing. All right, so this would be 3x cubed divided by 3, and so the 3's would cancel. Right, and so we have y equals x cubed, except it might be that we have some constant that we've lost, right? So it might not just be x cubed, it could be x cubed plus some constant. So a little review, right? So if we have y equals x squared plus 3, we take the derivative, we have 2x, right? If we have y equals x squared minus 5, we take the derivative, we have 2x. Well, those are two different equations with the same derivative. It doesn't matter whether the constant was 3 or negative 5. So when we take the derivative, the constant disappears. However, when we try to reverse the operation, we don't know what the constant is. It's lost. Lost to differentiating. So we put c in the answer to remind us that there might have been a constant. If we have some more information, then we can find c, right? So we're gonna so y prime, right? That's the same as, right, dy dx. That is the derivative. Right, so if we integrate y prime, right, we get y, right? Because if we take the derivative of y, we get dy dx, or y prime. And then when we integrate 2x dx, we would get x squared, and then plus c, because we have some constant that we don't know about, right? So now if they tell us that y is 4 when x equals 1, now we can find the exact equation. Right? We just plug in 1 for the x and 4 for the y, and we solve for c, and so now we see that c was 3. So an equation containing a derivative is called a differential equation. It becomes an initial value problem when you're given an initial condition. And so initial condition does not mean necessarily the y-intercept. You're just given some value, right? Some value for x and some value for y, right? They go together. And then we can solve for c, and we can find the original equation. So an equation involving a derivative is called a differential equation. The order of a differential equation is the order of the highest derivative involved in the equation. So this right here was a first degree because it was to the first power. It was the first derivative, not first power, first derivative. You could have a second derivative. And I think this is where the notes picks up. Yep, so now I think we're into what I already have posted. So I'm going to stop this podcast, right? And so you watch the second podcast. Bye for now.